Hi all, welcome to Clear and Concise. Let's have a look at this question. Here matrix A is given. We need to find the algebraic multiplicity of given matrix. First, let's understand what is meant by algebraic multiplicity of given matrix. In order to find the algebraic multiplicity, first step is to find eigenvalues of matrix A. Second step is count the occurrence of each eigenvalue. Okay, count of lambda I, that is equals to algebraic multiplicity. So first find the eigenvalues of given matrix. We know determinant of A minus lambda I is equals to 0 yields characteristic equation whose roots are eigenvalues. So now let's do this. That yield determinant of A is 0, 1, 0, 0, 0, 1, 1 minus 3, 3 minus lambda times I, that is identity matrix of same size as A, 1, 0, 0, 0, 1, 0, 0, 0, 1. Determinant is equals to 0. Now that yields 0 minus lambda, that is minus lambda. Again 1 minus 0. 1 minus 0 is 1. 0 minus 0, that is 0. Now consider this element 0 minus 0. 0 minus 0 is 0. Again consider this 0 minus lambda. So minus lambda. Third element, that is 1 minus lambda times 0 is 0. So 1 minus 0, 1. Third element, that is 1 minus lambda times 0 is 0. 1 minus 0, 1. Minus 3 times minus 3 minus lambda times 0, that is minus 3 minus 0 is minus 3. Again 3 minus lambda times 1, that is 3 minus lambda, whose det is equals to 0. Now determinant is equals to, determinant of A is equals to, what you can do is just take A 11 times cofactor of A11 plus A 21 times cofactor of A21 plus A31 times cofactor of A31. Here I have considered first elements of first column. You can consider elements of first row as well. It doesn't alter, but whatever the elements you take here, you have to find the cofactor of same element. Now let's see what is cofactor. A11 is, A11 from this matrix is minus lambda times cofactor is minus 1 whole power the index of this element, that is 1 plus 1 times minor of 1 1 plus A21 is, what is A21? A21 is 0. So 0 times anything is, now it is immaterial again, but minus 1, cofactor is minus 1 whole power this index, summation of index, that is 2 plus 1 times minor of 21 plus A31. A31 is this one, that is 1 times cofactor of 31, that is minus 1 whole power summation of index, that is 3 plus 1 times minor of 31. So this one will vanish because it is multiplied by 0. So anything multiplied by 0 is 0. This will get vanished. Now so here minus 1, 1 plus 1, that is 2, minus 1 square is 1. So it will be minus lambda times minor of 1 1. In order to obtain minor of 1 1, you have to delete first row first column. So first row first column I have deleted, and we need to find the determinant of remaining elements, that is minus lambda 1 minus 3, 3 minus lambda plus 1 times minus 1 whole power 3 plus 1 is 4, minus 1 power 4 is 1, 1 ones are 1, so minor 3 1. For in order to find the minor of 3 1, you have to delete third row and first column. So third row is this one, I am deleting this one, and first column is this column. So I am deleting first column and third row, then writing the remaining elements here, that is 1 0 minus lambda 1. Now let's find the determinants here. So minus lambda times determinant of this one is minus lambda times 3 minus lambda, that is minus lambda times 3 minus lambda minus 3 times 1, that is minus 3 ones are plus The determinant of second one is 1 ones are 1, 0 times lambda is 0, so 1. Now let's solve this equation, that is equals to 0. Now let's solve this equation to find the roots of the given equation, that in turn gives the eigenvalues. The equation we got is minus lambda times minus lambda 3 minus lambda minus of minus 3 plus 1 is equals to 0. That yields minus into minus plus, so lambda square 3 minus lambda minus into minus plus again, so plus into minus minus 3 lambda plus 1 equals to 0. That yields 3 lambda square minus lambda cube minus 3 lambda plus 1 equals to 0. Just multiplying both sides with minus yields lambda cube minus 3 lambda square plus 3 lambda plus minus 1 equals to 0. Now if you observe this, this is a cube and this is, let's say it is b cube. Here minus symbol is there, so it is in the form of a minus b whole cube, because a minus b whole cube is a cube minus b cube plus 3ab square minus 3a square b. Here a is equals to lambda, b equals to 1. You can see that a cube in the sense lambda cube minus b cube in the sense 1 plus 3 lambda plus 3 lambda minus 3 lambda square. This is what we got. So equation can be simplified as lambda minus 1 whole cube equals to 0. That yields lambda minus 1 times lambda minus 1 times lambda minus 1, that is equals to 0. So the roots are 1 comma 1 comma 1. So the algebraic multiplicity of lambda equals to 1 is 3, because 3 is occurring 3 times. So the correct answer is option C, 3. One most important thing here is the algebraic multiplicity of a matrix cannot be greater than its size. So you can eliminate this one directly, then you can choose one among these options. For this question the correct answer is option C.